The first improper integral in here is an excellent problem for discussion because there is an infinity on the lower limit and upper limit. Take a look at the graph. On the left hand side, we have x goes all the way to negative infinity. On the right hand side, we have x goes all the way to positive infinity. Based on the fact that the area under the x-axis is negative and the area above the x-axis is positive, so we can see that the area below the x-axis cancels with the area above the x-axis. So that tells me overall the integral is equal to 0. Is that true? This is what we have to find out. All right, so first of all, we break this down into two integrals. The first one is the area below the x-axis, where we have the lower limit for negative infinity all the way up to 0, and then the second integral is above the x-axis. The area is above the x-axis, where the lower limit goes from 0 to the upper limit positive infinity. So this problem is a simple u substitution. We simply let u equals to the exponent, which is negative x squared, and then du is equals to negative 2x dx, and then negative 1 over 2x du is equals to dx. All right, and then the x is going to be cancelled, and then we have a negative 1/2 in front of the integral. So don't worry about changing the lower limit and upper limit in terms of u. So when you integrate, we will just don't write the lower and upper limit. So before we get into that step, let's set up the improper integral. So we have limit as t goes to negative infinity, integral t to 0, and then x e negative x squared dx, and then plus limit as t goes to positive infinity, we have 0 to t, and then x e to the negative x squared, and then dx. All right, and then you integrate, so the x will be cancelled, so you have limit as t approaches to negative infinity. Let's do the change of variable. So we have a negative 1/2 outside of the integral, and then the x got cancelled. We have eu du. Do not write the upper and lower limit. And then the other one, we have limit as t approaches to infinity, and then we have integral. Oh, forgot the 1/2, so negative 1/2, the x got cancelled. We have eu du. Do not forget about writing the limit because that is not optional. And then we integrate, so we have limit t approaches to negative infinity, negative 1/2, the integral of e to the u is still e to the u, and then let's replace the x back to u, so we erase the u and then put the negative x squared in there, and then we write such that x goes from t to 0, and then we add limit as t approaches to infinity, negative 1/2 e to the negative x squared, such that x goes from 0 to t. And then we plug in the t to evaluate the limit. So we do the fundamental theorem of calculus. T approaches to negative infinity, we have negative 1/2 e to the 0 minus negative 1/2 e to the negative t squared, right? So e to the negative t squared. And then we plus, let's do the other one in square bracket. So we have negative 1/2 e to the negative t squared minus minus, so minus negative 1/2 e to the 0 power, so e to the 0 is equals to 1. And then we have negative 1/2 times 1 minus minus, that gives me a plus. So when you plug in the negative infinity, so when you think about this, when you plug in a negative infinity and then you square that, you get a very big infinity, right? So you have 1/2 e raised to the negative infinity. Okay, here you have negative t squared, and then you have t equals to negative infinity. So when you do the plug-in, this negative sign stays in there. So this negative sign stays, and then you have t to the, and then you have a negative infinity square. So after you square that, you have this negative sign and then infinity. So overall, you have negative infinity. So, and then you have e to the negative infinity. So e to the negative infinity, and then you have a plus. This is negative 1/2. And then that gives you a e to the negative infinity as well. And then this is a plus 1/2. Okay, and then the next line you have negative 1/2, and then plus 1 over 2e to the infinity, and then minus 1 over 2e to the infinity, and then plus 1/2. So the 2 1/2s got cancelled. These 2 1/2 got cancelled, and then you can cancel the 1 divided by 2e infinity. But however, e to the infinity is equals to infinity. 1 divided by 2 times infinity is just equals to 0. So basically, you have negative 1/2 plus 0 minus 0 plus 1/2. So overall, that is equals to 0. So that means we have a real number. So therefore, the integral is convergent. And then we say the area is finite. So finite area. So let's go back to the picture. What is that means? The area is finite. That means as x goes all the way to positive infinity or negative infinity. So let's take a look at the negative infinity side. So as x goes all the way to negative infinity, the distance between the x-axis and the graph is so small such that the area between the x-axis and the graph is tiny. Tiny means it's so close to 0. So that means the area is really determined by this region. So we don't really worry about the area as x goes all the way to negative infinity because that is so tiny, something close to 0. When you add up all the area, you are adding up a bunch of number that is so close to 0. So that doesn't affect the total too much. So the total really depends on the area, like around the peak. So that's what that means. So that's how we got a finite area. So that's the first problem. And then the next problem, we have the one in the middle in blue. So we have integral from 0 to infinity, x squared divided by the square root of 1 plus x to the third dx. All right, so let's do that. So let me switch to light blue. And then we do that, and then we do the sine theta one after that. So the next one we have from 0 to infinity, x squared divided by the square root of 1 plus x to the third dx. Alright, so this one we set up the improper integral, limit as t goes to infinity. We have from 0 to t, and then x squared divided by the square root of 1 plus x to the third dx. And then it is a u substitution problem, so we let u equals to 1 plus x to the third, and then du is equals to negative 3x, or positive. So we have 3x squared dx, and then we have 1 divided by 3x squared du equals to dx. So what is going to be cancelled? The x squared on top will be cancelled. And then we do the change of variable, so that is equals to limit as t approaches to infinity. T approaches to infinity. Don't write the upper and lower limit. We have a 1/3. The x squared got cancelled. So and then we have 1 divided by the square root of u, which is u to the 1/2 du. And then what I ask you not to do is u of infinity and u of 0. So this one, if you do it, you have 1 plus infinity to the third, and then 1 plus 0 to the third. So this one, you don't need to try this. All right, just don't write the upper and lower limit when you do the u. So in case you don't really remember your u substitution, you have x squared right here, and then x squared on top. So they got cancelled. So they got cancelled, and then I just, forget about it. They got cancelled. So let's just don't write them out. And then now let's integrate. So this should be something simple. We have limit as t approaches to infinity. We have 1/3, the integral of u to the negative 1/2 du. This is a simple power rule, so you have 1/3. I keep forgetting the limit. Limit as t approaches to infinity. We have 1/3 u to the negative 1/2 plus 1, that is a positive 1/2. The reciprocal of that is a 2. And then such that x goes from where to where? x goes from 0 and then all the way to t. So I don't want to write another line. I will just go ahead and then erase the u and then put the x back, so which is 1 plus x to the third. Okay, and then we do the fundamental theorem of calculus. Limit as t approaches to infinity, we have 2 over 3. So 2 over 3, and then square root, right? So we have a square root 1 plus t to the third, and then minus 2 over 3 square root 1 plus, you plug in the 0, then that will be a 0. Okay, and then you plug in the infinity. So you have 2 over 3, the square root of 1 plus infinity to the third power minus 2 over 3, the square root of 1 is just equal to 1. So you have the square root of infinity. So this one is the square root of infinity, which is equals to infinity. Think about the graph of the square root function. It's an increasing function starting at the origin, right? So as x approaches to infinity, y approaches to infinity. This is the graph of square root of x. So overall, you have infinity minus 2/3. You have a huge quantity minus a tiny little bit. So you have infinity. So what does that mean? That means we have an infinite area. And also, the integral is divergent. Alright, so that is the end of the second one. So we have one more to go. That one has a sine and cosine in there. That is a very interesting problem too. So let's get into that. So the next one I prepare for you is integral from 0 to infinity. We have sine of theta e raised to the cosine theta d theta. Alright, so let's replace the theta by t and then set up the limit. So limit as t approaches to infinity, we have 0 to t, and then sine of theta e cosine of theta d theta. This is a u substitution. We simply let u equals to the exponent cosine of theta, and then du is equals to negative sine of theta d theta. 1 divided by negative sine of theta du is equals to d theta, and then the sign will be cancelled, leave you a negative 1 in there. You do not need to change the 0 and the infinity. So let's do the change of variable. We have limit as t approaches to infinity, and then we have integral. Do not write the upper and lower limit, so the sign will be cancelled, and then we have a negative 1 in there. And then e raised to the u du. And then what about the u? U is equals to cosine. So oh, we are doing du, right? Okay, we don't put the u back to cosine. We just do the integration right now. So we have limit as t approaches to infinity. The integral of e to the anything is the e to the u is e to the u. So we have negative 1 e to the u, and then such that x goes from 0 to t, theta goes from 0 to t. And then I don't want to write an extra line. If you do want to write an extra line, let's just do it this time because we didn't do this for the last two problems. So let's write an extra line. So the extra line, we will just have limit as t approaches to infinity, negative 1 e to the cosine theta, such that theta goes from 0 to t. One thing that I really don't like is looks like there is no upper and lower limit right here. So this step, I don't really like it. So I wrote it. Let's leave it in there. I am sure that you can just erase the u, put the cosine back, and then put the 0 and t. And then we use the FTC, fundamental theorem of calculus. So t approaches to infinity, negative 1 e to the cosine t, and then minus negative 1 e to the cosine 0. Alright, and then we plug in the t, so we have negative 1 e to the cosine infinity, right? And then minus is a plus, e to the cosine of 0 is equals to what? Because when you look at the unit circle, at the origin, when theta is equals to 0 at the origin, what is the that point, the coordinate of the point on the circle? The coordinate is x equals to 1, y equals to 0, right? So cosine is x, so we have 1. So that is 1. So e to the 1 is just a constant value. And then what about cosine of 0? This is the second reason why I picked this problem. Give me the graph of cosine. So cosine is between -1 and 1. The range is jumping. Why do I put a -1 in there? It's jumping between 1 and -1. And then that starts at 0, 1. So looks like this. That is one period. And then this is another period, and then it keeps on going, right? So this is the graph of cosine theta. So what happened as x approaches to infinity? As you look all the way to the right, so cosine of infinity basically does not exist. Why? Because the graph is bouncing between 1 and -1. As x approaches to infinity, there is no way to determine that limit. So the reason is cosine. They use the word oscillates between -1 and 1. The range is jumping between -1 and 1. Oscillates means jumping or bouncing between -1 and 1. So it is impossible to determine what that equals to when x approaches to infinity. So we have a what? We have a cannot determine plus e to the first power. So this is cannot be determined. We have cannot determine plus e. That means overall the sum cannot be determined. So this one we say does not exist. Does not exist. I am not able to evaluate this limit. So what is does not exist mean? That means I am not able to determine the area at all. It's not just infinity. I'm not able to determine that at all. So in this case, we say that the integral is divergent. So that is your conclusion. All right, so that is the third integral we solved in this video. If you think my instruction is helpful and clear, give me a like, share the video for me, subscribe to my channel if you are new to my channel. See you all in the next one. Signing out for now.